Hey guys, my name is Necro, and it's tech time. I know that not everybody has the money to spend on top-of-the-line parts, but it's not actually necessary. And I'd like to take some time today to explain why. The average cost of a computer in 2015, so 2 years ago, was about $630, assuming you bought it pre-built from a large store. The average cost of a gaming console is about $300, assuming you're on the lower end, such as the original PS4 or Xbox One, or the upcoming Nintendo Switch. If you're buying the upgraded versions, like the PS4 Pro or the Xbox One S, you're looking at about $400 entry. The price is going to be even higher if you intend to play multiplayer, as each of these gaming consoles requires a subscription service to play online. So assuming you have both a computer and at least one gaming console, you're at a minimum of $1,000 out of the gate, and more over time if you continue to play multiplayer. But for this price, if you're building it yourself, you're talking an i5 on liquid, a Z170 board to support overclocking, 16 gigs of memory, and a GTX 1070. That's a pretty significant machine right there. The aim here is to create a hypothetical situation where you could build two of these machines for what you're already spending. As you already have two devices, you might want to keep them as two separate devices. Now don't get me wrong, I have nothing against console gaming. I have my PS4 right here beside me, and I love it. But there are a lot of advantages to gaming on a PC, and there's a lot of people out there that have the misconception that it's just too expensive. So I'd like to do my part, help everyone out, and maybe help build it come time for your next computer. Now, to be completely honest, this challenge is still too easy. You can always go online and find people selling enthusiast level components at nothing. I just looked online on eBay, and on the first page alone, I already found somebody selling an i7 6700K bundled with 16 gigs of memory and a pretty decent aftermarket cooler in the 212 Evo. Total price is about $250. Current prices, buying these brand new, is at least $400. And when they were all brand new components, that would have been about $500. So you can see how easy it would be to build a pretty killer machine for $500 if you're buying used parts. However, not everybody is comfortable buying used parts. The average consumer probably wants to keep that warranty, and they also may not know how to inspect or clean or fix some of these components. So, I'm going to limit myself and say I'm only using brand new parts, and I'm also going to limit it even further by saying I'm only going to use parts that are compatible with the latest gen tech. The reason for this is I want to lay down an upgrade path as well. So if somebody were to build this machine, they could very easily upgrade it without having to completely overhaul or replace the motherboard. Now, this isn't going to carry through indefinitely. AMD has already said they're going to be using a new socket for their Ryzen CPUs coming out, and that's going to be the AM4 socket. And Intel, they haven't announced what their Coffee Lake is going to be on. It very well might be the 1151 still, as it is just another revision of Skylake, just like Kaby Lake was, but we don't know. So we're just going to go with what's out now and not worry about what's coming out in the future. General rule, though, you shouldn't ever try and build a computer that's future-proof. Building a computer that's strong enough to last a couple years, that's doable. Future-proofing, as in being able to always upgrade it without gutting it, it's never going to happen. You don't know what the new sockets are going to be. You don't know how parts are going to be compatible. There's even in the Kaby Lake processors, there's functions of that processor that are only functional if you're using Windows 10. So sometimes it's even operating system reliant. So don't try to future-proof your computer, and don't let anybody talk you into doing that either. Oh, side note, we're also not going to be overclocking. If we're talking about building a budget machine for the average user, especially one just getting into computers, probably is not comfortable going into the BIOS and tweaking with their multiplier or their voltages or anything like that. So we're just not going to do it. So without any further ado, let's just go ahead and jump right in and build ourselves a $500 machine. Now, to get this out of the way, let's go ahead and talk CPU. That's going to be the core of the build, no pun intended. And it's also what we've got to design the rest of the build around. I've decided to go with an Intel processor. The main reason being is that even the most advanced chips from AMD, like the 9350, can, in some instances, result in a bottleneck for your graphics card. Now, this would only be if you have a 1070 or a 1080 and you're running a very CPU-bound game that still has pretty advanced graphics. If you're trying to run something like Battlefield 1, for example, or Dishonored 2, you could see some limitations in that instance. The processor we've chosen, however, the G4620, will also result in some bottlenecks. But the logic here is that it's got the path forward, whereas the AMD chips do not. The 4620, if you wanted to upgrade, all you'd have to change out would be the cooler. You could easily throw in a Skylake or Kaby Lake i5 or i7 and just keep on going. Whereas with AMD, if you wanted to upgrade, you'd have to go to Ryzen, which would mean a whole new motherboard, which, depending on what your build is, may also mean a new memory kit, and I don't see that changing anything else, but it's technically possible. Also, keep in mind, our goal here is to build a computer that will operate doing everything the average user will do, while also being able to game with a minimum of settings and performance comparable to the PS4 or the Xbox One. We're not looking at enthusiast level performance here, just the ability to do everything the current consoles can, and the ability to upgrade later on to keep up with any new consoles that come out. Now, as far as cooling goes, we're going to actually be sticking with the stock cooler. Reason being is we can overclock it, so as long as the airflow in the case is fine, the stock cooler will be plenty, keeping in mind that this is only a 51 watt TDP on this processor. Next, let's talk motherboard. Since we've already established that we're not going to be overclocking, we don't need a Z170 or Z270 chipset. Also, as an added bonus, let's try and keep it at a smaller form factor. As a fan of ASRock myself as far as budget motherboards go, I've decided to go with their B250M HDV. It's in the micro ATX form factor, and it has all the features you need, as well as some pretty nice features that you don't, such as an M.2 slot. A lot of people who aren't into computers might not know what that is. It's a slot that uses your PCI lanes directly on the motherboard that you can put a special type of solid-state storage directly into. So you're not running through SATA, you're going to be looking at significantly better speeds than any SATA drive could possibly have. We're not getting one right now, but it's really cool that a board in this price range has that potential. For the memory, I've decided to go with a single DIMM of Crucial's Ballistics Elite, 8GB running at 2666. While the board and CPU only handle speeds up to 2400, there's no harm in going any faster, and more than that, there's no price difference between the two. So even if there's no performance difference, it doesn't hurt anything. And it's entirely possible that as the memory is rated for higher speeds, having it run slightly slower could, in theory, add some stability and reduce temperatures slightly. I don't think it'll have too much of an impact, but as I said, zero price difference, and it doesn't hurt, so why not? For storage, pretty simple solution. WD Blue 1TB drive. It's cheap, it's reliable, and it's got decent speeds as far as mechanical drives go. For graphics, we're going with EVGA's superclocked 1060 and the 3GB version. At $200, it's a great card, and while it doesn't have the 4 gigs of VRAM that the RX 480 or the 1050 Ti do, that extra gig of memory doesn't actually add a whole lot at 1080p. You will notice a difference if you are doing anything with super high resolution textures, or if you're trying to game at 1440 or 4K, but at 1080p, normal gaming, extra gig's not going to have that much of an impact. As far as why I went with the 1060 over the 480, since they're in the same price point, honestly, it's mostly just a preference thing. If you're an AMD fan, by all means, go with the 480. The only significant difference, and I say significant loosely, it's actually fairly minor. The only difference is that the 1060 is about 30 watts lighter on the TDP when compared to the 480. Not the biggest difference, but it is enough where it could impact performance and cooling a bit. For the case, we're going with the Xeon XON310. It's a nice form factor, nice size, plenty of clearance for all of our components now and any components we'd want to upgrade to in the future. Looks pretty decent. Only complaints I would have about its cable management, really. But considering it doesn't have a window, you're not going to be seeing it, so the aesthetics don't really matter all that much. It might be a personal pride thing for you, but you're not going to see it unless you're opening the machine. As far as cooling goes, cable management does not impact cooling as much as a lot of people claim it does. So you should be fine with a smaller case like this. And last but definitely not least, the power supply. Here, pretty baseline EVGA 430 watt 80 plus rated power supply. Current system, as it sits, only uses about 250 watts of power, so we have plenty of overhead now and for any upgrades later. If you did go the whole 9 yards, get the GTX 1080, get an i7, a pretty banging aftermarket cooler, and throw in another DIMM for 16 gigs of memory, you'd still be under limit. You're talking about 370 watts of use max then, still under 430 that we have here in this power supply. Now, if you did upgrade that far, I would probably recommend going higher, probably to about a 500 watt, just because you do want to stay under 80% of the power supply's load for peak efficiency. So, there you have it. After everything said and done, including taxes and shipping, you're sitting at about $530 for a computer that can run every game on the market right now at 1080p at decent settings, if not all the way at max. Now, as far as upgrades go, you have a lot of paths open for you right now, but the first upgrade I would recommend, and it is a strong recommendation, is the CPU. While the 4620 can do everything on the market right now at settings that are decent without being painful to play, it's still the weakest component in this build as far as gaming goes. For another $100, you can get the i5-7500, which is a true quad-core as opposed to the hyper-threaded dual-core we have now, and that will significantly improve your performance. Now, as far as the second upgrade, that actually depends on whether or not you have the computer and you're adding to it, or if you're changing the build before you start. If you already have the computer, I would recommend getting a second stick of memory to upgrade to 16 gigs. If you are changing it to start with, I would actually change that 1063 gig to the 6 gig version. While the 1063 gig is more than enough for 1080p at 60 FPS, the 6 gig version is actually a more powerful card despite them having the same GPU. The 3 gig version has some of the CUDA cores deactivated, so you will see a significant performance difference between the two. Even if you are only using a 60Hz monitor, you will still notice a marked improvement, as your FPS is an average across that second and not a flat value. So the higher your FPS means the less noticeable those valleys in your frame output are going to be. From there, the next upgrades are really up to you. Whether it's a GTX 1070 to push you solidly into that 144 frames per second zone, or a Z270 chipset motherboard to allow for overclocking and then some aftermarket coolers or maybe even water cooling. The choice is yours. Now, unfortunately, I don't have the money for the parts right now to take you through the process of building this and then recording any benchmarks live for you, so you are going to have to take my word for it to a point. I would not recommend buying off of anybody's word alone. Please always do your research before this sort of investment. But I am confident that this is at the very least a good springboard for starting your build at this price point, and you can finagle it as you see from there. Thank you guys for watching. If you liked it, give it a thumbs up. If not, thumbs down. And if you'd like to see more, please subscribe. As always, suggestions are always welcome, so if there's something you would like to see, leave a comment below, and I will catch you guys next time. Said even a thing. Indigestion. God damn it.